Okay, this is concept 65 following from 64. I apologize for the audio quality on the last video. I swear I'm not shouting into the mic. The quality on this dot cam is just really terrible. I'm going to try to whisper to see if that helps with the quality. Apologies ahead of time too, because I think you could hear the fan in my room, and you might hear my dog or just other people in the house. But anyway, concept 65 deals with simplifying trig expressions. To simplify a trig expression, it means to rewrite it as a numerical expression or in terms of a single trig function. Identities are useful in simplifying trig expressions. So what does all this mean in one thing? You're given an expression, make it into just one trig function. Some strategies here: rewrite using reciprocal and quotient identities, super key, look for Pythagorean identities or a possible way to create one, same thing. Okay, combine fractions using common denominator, cannot get stuck with fractions, break fractions apart, use factor. Okay, I will be referencing the ones from the previous lesson a lot. Okay, the quotient identities, the reciprocal identities, and the Pythagorean identities. These three, along with the ones we have rewritten here, okay, will be strongly referenced here. Okay, simplify each expression. Here's the first one. Secant theta, I know, is, and again, the hardest part is starting these problems. Start them, okay, apply an identity and see if you're able to go anywhere from there. Do not ask for help where the question is, how do I start this? Okay, because if I keep giving you these identities, if I do that step for you, trust me, you're gonna have a hard time on the test. That's the whole point. These things are hard. Okay, anyway, secant theta, that's 1 over cosine theta. Okay, so secant theta is this one, minus sine theta. Tangent theta is sine theta over cosine theta, and these are being multiplied. Okay, alright, sine theta times sine theta over cosine theta, that's going to become cosine theta minus sine squared theta over cosine theta. Again, when you multiply these, that's what I got here. Okay, I have a fraction minus a fraction. I have common denominators, so that means I can make this into one fraction. 1 minus sine squared theta over cosine theta. 1 minus sine squared theta, this is an identity. Okay, in the previous lesson, it's right here. 1 minus sine squared theta, that's cosine squared theta. So I can say then the top is cosine squared theta over cosine theta. Okay, so then I can cancel these then. Cosine theta on the bottom with 1 on top. This is like having x squared over x, right? 1x goes away from top and bottom. And so then your answer is cosine theta. Okay, that means this is just cosine theta. Next one, sine theta plus cosine, sine A plus cosine A times tangent A. Alright, I have sine A plus cosine A. Tangent A, that's sine A over cosine A. And again, I'm grabbing these from here, okay? How do I know tangent A, sine A over cosine A? It's right here. It's a quotient identity, okay? Alright, these guys, I have cosine theta times sine theta over cosine theta. Cosine A's cancelled, so then that gives me sine of A plus sine of A. Sine of A plus sine of A, how many sine of A's do you have? 2. 2 sine A. There you go. That's your answer. Next one. Cotangent squared u minus cosecant squared u. Let me see. There's 2 ways you could go about this one. There's a quicker one, but I do want you guys to get used to using the sine and cosine where they're used as an identity. Okay, so cotangent squared u, this one would be cosine squared u over sine squared u minus cosecant squared u. Cosecant is the reciprocal of sine, so then 1 over sine squared u. You have a fraction minus a fraction, same denominators, so then this would be cosine squared u minus 1 over sine squared u. I can combine those fractions. Cosine squared u minus 1, this is an identity. Okay, it's right here. Almost an identity, actually. It's not quite, I was wrong. I have cosine squared u minus 1. Here I have 1 minus cosine squared theta. So the orders are switched. So in order so I can get that order, what I'm going to do is I'm going to factor out a -1 from the numerator. So what that lets me do is then I'll have 1 minus cosine squared u. Okay, again, by factoring out a -1, I'm able to switch the order and the signs. The 1 is now positive because if I distribute this back in, -1 times +1, that gives me a -1. I have negative cosine squared u, but if I distribute this in, negative times negative, it becomes positive like I have here. Okay, so that's all that happened here. All over sine squared u. This is the identity I showed in the previous page. This is sine squared u. So then -1 times sine squared u over sine squared u. It's a fraction. These guys cancel. And so then your answer is just -1. Okay. Number 4. What I'll do here is I'll distribute the sign in. Okay, this will give me sine x times tangent x plus sine x cotangent x. Again, all I did was I distributed sine x into each one. Okay, all over cosine x. Alright, next I'm going to apply the identities. So then I have sine x, that's this guy. Okay, tangent x, that's sine x over cosine x. Okay, so times there, plus sine x times cotangent x, that's cosine x over sine x, all over cosine x. On this term here, sine x times cosine x over sine x, these guys go away. And then right here, sine x times sine x, I'm going to have sine squared x over cosine x plus, let me see here, plus cosine x. And then that's it, because the sine x canceled, and that's all over cosine x. I'm starting to remember this one from class. I think I started it this way, and then I had to backtrack on it. No, let's keep going. Okay, so then I have cosine x over 1. So I can combine these two fractions in the numerator. I need to make sure this one's also over cosine x. So I'm going to multiply this one by cosine x, top and bottom. That'll give me sine squared x over cosine x plus cosine squared x over cosine x, all over cosine x. Now I have fractions I can combine on the here top. So then that'll become sine squared x plus cosine squared x all over cosine x, all over cosine x. Again, this top set of fractions here, I merge into just one. Okay, sine squared x plus cosine squared x, that's a Pythagorean identity right here. Okay, when I add them and they're squared, that's equal to 1. So then I have 1 over cosine x over cosine x, fraction divided by number here. Okay, don't forget, you multiply the reciprocal. This is like having cosine x over 1. So then this will be 1 over cosine x divided by becomes multiplication, reciprocal, 1 over cosine x. This will give me 1 over cosine squared x. 1 over cosine squared x, that is secant squared x. So that's your answer. Let's see. Let's do 5. We'll skip 6. So for 5, I have cosecant theta minus cotangent squared theta over cosecant theta. For this one, what might be the way to go about it? Let's see. I'll have 1 over sine theta, whoops, not equals, minus cotangent squared theta over cosecant theta. The top here will become cotangent squared theta, so cosine squared theta over sine squared theta, all over cosecant theta, which is 1 over sine theta. So for just the right side here, I still have the 1 over sine theta, that's him. Okay, for this one, I have a fraction over a fraction, multiply reciprocal, that'll be cosine squared theta over sine squared theta times sine theta over 1. That sine will cancel out with 1 from the bottom there. So then I'll have 1 over sine theta minus cosine squared theta over sine theta. Now I have two fractions with a common denominator, so I'm going to combine them. This would be 1 minus cosine squared theta over sine theta. The top here is an identity, 1 minus cosine squared theta. It's this one right here, that's sine squared theta. So then sine squared theta over sine theta, those will cancel, and so you're left with just sine theta. Okay, skip 6, turn the page. Excuse me. So yeah, let's do 7. Yeah, let's do 7. 7 says secant u over sine u minus sine u over cosine u. So I can combine these. I will have to get like denominators, so I'll multiply the second one by sine u and the first one by cosine u. Okay, and what this will do is I'll have this as my result. I'll have cosine u times secant u over cosine u sine u. That's the first one by just multiplying that in, minus sine squared u, because sine u times sine u, sine squared u, and then the bottom here will be cosine u times sine u. Notice now that the denominators are the same, so then I can write this as just one fraction. So all of it will be over cosine u times sine u. For the numerator, okay, let's do free. There it is. Nope, there you go. Okay, cosine u. Okay, secant u, that's 1 over cosine u. So times, minus, and then I have sine squared u. So then The cosine u's here will cancel. Then I will have 1 minus sine squared u on top, all over cosine u sine u. 1 minus sine squared u, that's an identity. That's this one right here, that's cosine squared u theta. So cosine squared u over cosine u sine u. This guy will cancel out with him. That gives me cosine u over sine u. Cosine u over sine u, that's an identity, that's cotangent u. Okay, how do I know that? Again, it's in your previous concept right here. Cotangent is cosine over sine. Cosine over sine, that's cotangent. Okay. I think we do have to do 8. Okay. 8, I have tangent alpha over secant alpha minus cosine alpha. So then tangent will become sine alpha over cosine alpha, all over secant alpha, that one is 1 over cosine alpha minus cosine alpha. Okay, cosine alpha over 1. So then for the bottom, I'm going to have to multiply by cosine alpha so that I can combine these two fractions. I need like denominators, and only the second term, because this one already has cosine alpha, so I'm only worried about the second one. This will mean then I have sine alpha over cosine alpha, all over, this will be 1 over cosine alpha minus cosine squared alpha, because that's these two cosines multiplied, over cosine alpha. Okay, so then this would be sine alpha over cosine alpha, all over, I can combine the two fractions now because they have the same denominator, 1 minus cosine squared alpha over cosine alpha. That's equal to a fraction divided by a fraction. Okay, multiply reciprocal, so then sine alpha over cosine alpha times, whoops, I made a hole there, cosine alpha over, I'm taking the reciprocal here, 1 minus cosine squared alpha, yes, that's an identity. 1 minus cosine squared alpha, that's sine squared alpha. So then I could just go ahead and sub it in already. Sine squared alpha. This guy will cancel there. Sine alpha will cancel out with 1 there. So then this one will be 1 over sine alpha, which is 1 over sine, that's cosecant alpha. Okay, 9. Foil, right? I have a binomial here and a binomial here. Okay, FOIL it out. Cosecant x times cosecant x, cosecant squared x, cosecant x times -1, that's a -1. That'll be negative cosecant x, 1 times cosecant x, positive cosecant x, 1 times -1, all over cosecant squared x, negative cosecant, positive cosecant, these guys cancel out. So then I'll have cosecant squared x minus 1 all over cosecant squared x. Cosecant squared x minus 1, that is an identity. I have it right here, cosecant squared minus 1, that's cotangent squared theta. So then this one will become cotangent squared x over cosecant squared x. Cotangent is cosine squared x over sine squared x. Oh shoot, I misspelled that. Sine squared x, cosine squared x over sine squared x, over cosecant squared x, that's 1 over sine squared x. Fraction over a fraction, multiplied by the reciprocal, that'll give me here's the numerator, that's this guy, okay, times reciprocal sine squared x over 1, okay, sine squared x's will cancel out, and so cosecant squared x over 1, that's just, not cosecant, sorry, cosine squared x, and that's your answer. Okay, last one, number 11. Have tangent squared y minus tangent squared y times sine squared y. Both of these have tangents. I'm going to factor out a tangent squared y from both of them. That'll give me 1 minus sine squared y. Again, if I distribute this in, I get the original. Tangent squared y times 1 is this guy. Tangent squared y times sine squared y, that's this guy. Okay, so I factored this out. 1 minus sine squared y, that's an identity. That's this one here, that's cosine squared theta. So then I'll have tangent squared y times cosine squared y. Tangent squared y, that's sine squared y over cosine squared y times cosine squared y. These guys will cancel, and so my answer is sine squared y. Okay, that's it.